These are the 6.3 notes for trig. We're going to talk about using the unit circle. So if you have not already watched the video or filled out your unit circle, please make sure you pause this video, stop it, do that first. Our essential question, how do I find values using the unit circle? So what's the difference between the inside numbers and the outside numbers on your unit circle? We talked about this when we filled it in, but the inside numbers are the angles. And you either have degrees, like this 30 degrees, or you have this pi over 6 value, which would be your radians. And those are just two different ways that we measure angles, degrees and radians, and those are the two inside numbers. Then on the outside, you'll notice you actually have points, or the values. And those are listed as XY pairs. So notice right there you have 1, 0. Over here, you have negative square root of 3 over 2, 1/2. Again, if you haven't filled out your unit circle, go make sure you do that first. All right, and then actually, how do we use this unit circle? So how do I find values of sine and cosine? Sine and cosine are pretty simple because sine is just the letter y and cosine is just the letter x. So all we have to do is look at our unit circle at the correct location, and then we'll find the exact value. And remember, the values are the numbers on the outside. So for the sine of 60, you would go to 60 degrees right here. And sine is y, so your value would be radical 3 over 2. For cosine of 135, find 135. Cosine is the x value of that point. So your answer would be negative square root of 2 over 2. This is going to be a lot easier if you have the large unit circle that you can kind of look back and forth with. Cosine of 270. Here's 270. Cosine is your x. You just write down 0. Sine of 210. Here's 210. Sine is y. So you have negative 1/2 as your answer. Works the same way for the radians. Cosine of 7 pi over 4. 7 pi over 4 will be down here. And we're looking for cosine x, which would be square root of 2 over 2. And then the sine of pi. Here's pi. Sine is y. And you'll get an answer of 0. So for sine and cosine, you're just looking at either the letter y or the letter x. Now for the next part, tangent. Tangent we know is y divided by x. Or if you have whole numbers, you could write it as y over x. A lot of the values on the unit circle are fractions, so this is going to be kind of the best method for that. So when you look at the tangent of 30, you'll notice that the y value for 30 is 1/2. So it's y divided by the x value at that same location. I'm going to go back to the unit circle so you can see it, but once we get past this one, I'm just going to assume that you're still looking at the unit circle on your own. So let's go to 30 degrees. Erase some of this stuff. All right, so here's your 30 degrees, all right? And so that for tangent, you're going to take the y value, 1/2, and divide it by the x value, radical 3 over 2. All right, let's go back to our problem and actually divide those out. When we divide fractions, we flip the second fraction and we multiply. So Look at something that looks like this. Here the 2's can cancel. I get 1 over the square root of 3. I'm not allowed to relieve the square root of 3 in the denominator, so I'll rationalize by multiplying by the square root of 3 over square root of 3. That's something we've been simplifying for the last couple weeks now. So this would give me the square root of 3 over 3. Example 8, the tangent of pi over 4. So go to pi over 4, take your y value, radical 2 over 2, divided by your x value, radical 2 over 2, and flip the second fraction and multiply. This time both of those cancel out and you're left with an answer of 1. Example 9, the tangent of 60 degrees would be the square root of 3 over 2 divided by 1/2. So very similar to example number 7, just the numbers are switched around. Radical 3 over 2, flip the second fraction. Cancel the 2's. And I'm left with radical 3 over 1, which I'll just leave as radical 3. For the tangent of 0, since at 0 your points are both whole numbers, I'll go ahead and divide it out as 0 divided by 1, just like that. 0 divided by 1 is 0. And then for tangent of pi over 2, y is 1, x is 0, and when you divide by 0, you do not get an answer. This is what we call undefined. Now what we're going to do is we're going to take your unit circle, the one that's on the big piece of paper, the full page of paper, and filled out, and we're going to put our tangent values on the unit circle. Put onto unit circle. And that's going to save us from having to divide every time. Let me show you what I mean. And again, you're going to want to do this on your full piece of paper, the full unit circle. I'm just going to write our answers in. So we said that tangent of 0 was 0. Tangent of 30, it was the square root of 3 over 3. Tangent of pi over 4 would be 1. Tangent of 60, square root of 3. And tangent of pi over 2 would be undefined. And just like the rest of the points on our unit circle, the tangent values are very symmetric. So if you notice right here compared to right here, the only thing that's changing is there is a negative. So when I divide those, the only thing that's going to change is my answer will be a negative. So I'm just going to copy that directly over. Same thing for the 1, I'll just make it a negative. And same thing for the radical 3. So you'll see that those 2 points are going to be the same, and those 2 points are going to be the same, and those 2 points will be the same. All right, we'll continue this pattern. Moving now numbers up and down. I can move that 0 straight across. There's no negative 0, so that won't change. And then down here, again, notice this point is the exact same as that. I have 2 negatives this time when I divide, 1, 2, so that'll give me a positive radical 3 over 3. And then a positive 1 and a positive 3, radical 3. Then this undefined is going to travel all the way directly down. And I'll write undefined right there. Then the last quadrant, you're again just going to copy these numbers over. So notice this point is the same as that point. The only difference is how many negatives you have. Over here on the right side, you only have 1 negative, which means that when you divide, you will be left with a negative. So these two are the same, except for the positive versus negative. Same thing on the next one. Those two would be the same. -1. These two would be the same. Negative square root of 3 over 3. All right, let's clear that circle up a little bit. And make sure you have all those values. Again, you could write it on this one, but I would suggest writing on your big unit circle. You're going to have more space. And maybe you even leave a little note that these are the tangent values. All right, so you know. All right, so we've taken care of sine, cosine, and tangent. The next thing we're going to work on is our secant, cosecant, and cotangent. Now, for each of these, we are going to have to do the math because there's just not enough room on our unit circle to write all of these down. So whenever we do cosecant, we're just going to need to flip the y value. Y is sine, and cosecant pairs up with sine. For secant, we're going to need to flip the x value. And for cotangent, we'll flip the tangent value, which remember is those ones we just wrote on the outside. Cosecant of 60 degrees. I'm going to go to 60 degrees. I'm going to find the y value, and I'm going to flip it. 60 degrees. Find the y value, and flip it. When I flip it, I get 2 over the square root of 3. Go back to my problem. 2 over the square root of 3. Now I just have to rationalize the denominator by multiplying by radical 3 over radical 3, which gets me to radical 3 over 3. All right, for the secant of pi, secant is x, so I'm just going to think about flipping my x. When I look at my x value for pi, I get -1. Right? Technically, there's an over 1 there because that's a whole number, so I flip that and get 1 over -1. Sorry for all the scrolling. I could not find an easy way for me to show you the unit circle and do the examples, so thanks for bearing with me. 1 over -1, that just gets me -1. Cotangent of 7 pi over 6. Go to tangent, 7 pi over 6. It's radical 3 over 3, so we flip it. Get 3 over radical 3. And then we multiply. Get 3 radical 3 over 3. And then something happens. If you notice, you can actually cancel these 2 regular 3's. And you're just left with the square root of 3. For cosecant of 5 pi over 4, again, you would be flipping the y value, as opposed to here that you flipped the tangent. The y value is 2 over negative radical 2. And so we'll multiply by square root of 2. Square root of 2. You don't have to multiply by a negative. The negative can just stay out front. And we get 2 square root of 2 over 2 with a negative there. The 2's can cancel even though there is a negative. That negative is being multiplied, so it can kind of just hold its own. And then because you don't have anything else in the denominator besides the negative, you can go ahead and bring the negative up to the top and attach it to the square root of 2. All right, one thing I want you to notice, for each of these directions, it said use the unit circle. Anytime it says use the unit circle, use the unit circle means use X and Y, not O, A, and H. Okay, there's no SOHCAHTOA here if it's asking about the unit circle. Use X and Y, not O, A, and H. And you're just literally looking for the words use the unit circle or find the value. All right, that's it for today. If you have questions, please let me know.